All right, we are recording. So for the 8 million people who are listening at home today, hi. We are going through 2B-9. I'm not checking it off today for problems 1 and 2. We're going to do 1, 2, 3, and 4 for tomorrow. So by the time you're watching this, hopefully it'll be relevant. 1 and 2, we're just going to work it together because there's a little bit of confusion. The entire thing is due tomorrow, i.e. Wednesday. And this isn't the right date. November 30th. It's part Mr. Plain's handwriting, part mine. All right, take out your notes and/or worksheets. Probably the worksheet will work. Number 1, I did want you to replace 0 with y. So negative 2x to the 4th plus 5x to the 3rd plus 79x squared minus 180x minus 252 is less than, and instead of 0, put a y. Now they did write it backwards, which is a bit annoying. Quick question, oh logic people. If this whole mess is less than y, then y must be what? Compared to it. Greater. So I'm going to rewrite it in the right order. Negative 2x to the 4th plus 5x cubed plus 79x squared plus negative 180x plus negative 252. Okay, so there's step 1, get in the right form. And how do we graph? Bring this thing over here. How do we graph? Let's unplug everything. How do we graph something that big and monstrous? Well, where are we? Oh, that's funny. That's not even the one I want. Hang on. Give me a quick second here. Freak out. For people listening at home, this is going to be incredibly boring for about 30 seconds, so feel free to fast forward. So, homework 2B-9. Got it. That's much better. All right. 5 terms. Question, can we factor by grouping? No. Is there any other way of factoring, like GCF or anything? No. People listening at home, I'm terribly sorry, I'm hanging up my blazer, so there's a bunch of dead air space with absolutely nothing in front. I'm not gone. So, hi, I'm still here. Yeah?
Can we do a GCF of negative 1?
Interesting point. Yes, you could if you wanted. Y is greater than, it's not going to be incredible difference, but 2x to the 4th plus negative 5x cubed plus negative 79x squared plus positive 180x plus positive 252. Yeah, definitely. Now it looks like we're stuck. So the only option is what? Oh, math people. Go. Synthetic division. Start guessing. In other words, see if you can guess some roots. Tell me something about this first. All the stuff we've learned in this chapter should narrow down our list a little bit. So can somebody tell me, first of all, Megan, how many roots are in this thing total? 4. How do you know that? Yeah, the highest power is 4, the degree is 4, so it has to be 4 roots. Can somebody tell me the possible number of real roots? Jeff?
4 or 2 or 0.
Yeah, real roots, they could be all 4, or there could be 2, or there could be 0. We don't know quite yet. How about non-real roots, Blaze? How many of these could be non-zero or non-real?
0, 2, 4.
Correct. 0 or 2 or 4. Because non-real roots always come in pairs. Any radical roots come in pairs. And that covers that. Can somebody tell me how many positive roots? Very clear. How would you find out?
Do the number of sign switches?
Right, and I would do it before you factor it out. I mean, it works either way. It'll work. So sorry. Yeah, the tower of power is in your way. How many side switches in the regular one?
2.
Yeah, one switch here. This is the same, and one here. So let's say there are 2 side switches. So 2 positive roots, or possibly what? Or possibly 0, because they might go missing as non-real roots. Negative roots. Nick, how do you find that out?
Is it put in a negative x?
Right. This is f of x. And now I want to check for f of negative x. What would that be? What's the quick way to do that? Plugging in negative is the technique, but is there a quick way to?
Odd powers change.
Switch the odd powers. Does this one switch or no?
No.
So negative 2x to the 4th, keep going.
Yep, that does.
So minus 5x cubed, keep going.
That one stays the same.
Okay, so just read it out.
Positive.
Uh-huh.
79.
79x squared.
That is positive.
Yes.
180x.
That's 180x.
Minus 256.
252, but yeah. How many sign switches are in that thing?
2.
2. There's one here, one here. So how many negative roots?
2 or 0.
2 or possibly 0. Right. So that didn't, sometimes we get lucky and they say there are no positive roots or no negative roots, and that eliminates a lot of ours. Not quite so lucky as that. Can somebody tell me the interval where the roots can be found? And I will tell you right now, this is not very helpful. Okay.
X is between negative 252 and positive 252.
You're correct. Yeah, and I apologize for the almost useless interval. So yeah, that'll leave 505 numbers to guess, not counting fractions. Yeehaw. Can anybody tell me the list of all possible rational roots? Josh. How do you get the possible rational roots? From the rational root theorem, how does it work? I'll give you a hint.
Well, is it factors of the first or factors of the last or factors of the first?
Factors of the last over factors of the first. And I heartily apologize for this one, but yeah, go for it. 1 and,
2 and 2.
yeah. It's not as bad as you think, because it actually breaks down into, well, actually it is pretty bad. So keep going. Does 2 work?
Yeah.
For what? Excuse me. 2 times is what? And by the way, you are allowed to use a calculator on this coming test. This is actually one time where a calculator does come in handy. If you have a monster for a last term or a first term, you can find the divisors. So 2 times what?
126.
Mm-hmm. Does 3 work?
Yeah.
Yes, it does. 3 times what?
84.
84. How about 4?
Yes.
Yes. Here's a quick, you notice 2 went with 126? There's a try, I don't know if I showed this to you or not. If you take the first number and make it twice as big, take the second number and make it twice as small. And if it goes evenly, then you just found 1. What's half of 126?
63.
Yes. Does 5 work? How about 6? Look at 3 and 84. If I double this, can I cut this in half?
Yeah.
Go for it.
42.
Exactly. And that's the nice thing, you don't even need a calculator for that. Does 7 work?
Yeah.
Yes, it does. You'll have to do that fresh, sorry. 7 goes into 252,
36.
36 times, correct. Does 8 work? Here's 4 and 63. 8 will not work, because you cut 63 in half, you don't get a whole number. How about 9?
Yeah.
Yes. 9 times what?
28.
Say again?
28.
28, correct. Does 10 work?
No.
How about 11?
Mm-hmm.
How about 12? Here's 6 and 42. You didn't. If I make this twice as big, can I make this twice as small?
21.
Yeah, 12 and 21. Take over, Katie. Does 13 work?
No.
Correct, it does not. How about 14? Look at 7 and 36. And 18, correct. Those are awfully close to each other, so you might be done. Does 5 work? How about 6? What am I saying? 15, sorry. And then 16, look at 8. Did 8 work? No, then 16 won't work. And we've already passed the halfway point, so that's it. And go ahead and polish off the last one, even then. 1 and 2. Everybody okay with that? I'm not saying emotionally having a good reaction to that, but does everybody understand? Yeah, you do not have to write those all out as fractions. That's enormous. All right. Where would you start guessing? 1. Yeah, I would. Let's try this. Now we're going to try it with the original one without pulling out a -1. It should work if you pull out the -1. Just try it with the +2, -5. It should work either way. So let's try this. 1 is the box number. Let's try -2, 5, 79, -180, and -252. Here, by the way, I would recommend you do 2 things. This is a relatively large number and a large problem. So, A, you'd definitely be forgiven for having a calculator in front of you. Does anybody need one, by the way? Everyone want to borrow one? Okay. Second, there is a trick for finding out if it's going to work or not. Watch the numbers on the bottom and see if it's going out of control. We're hoping to get a final answer of 0. If it looks like it's going nowhere fast, you can stop. Just make absolutely sure. So talk me through this. Nick, come in.
-2.
Yep.
-2.
Okay.
3.
Mm-hmm.
3.
Uh-huh.
76.
That's positive though.
Oh, shoot. 81. No, 82.
82. Okay.
82.
Uh-huh.
98.
Yeah. Almost.
-98.
-98.
-98.
Is this going to work?
No.
No. It's some negative number. I don't even care what negative number it is. It didn't work. What's the next guess? Go. -1. That'd be my logical guess. So -2, 5, 79, -180, -252. By the way, I will say this much. This will not be true in real life. It came out wrong. No, this is real life, but it's math. But if you're like in the wide world doing a job or something like that, you might just have to guess 40 numbers. On the test, since we only have a limited amount of time, I will make sure that one of the roots is nice. It'll either be 1, -1, 2, or -2, or maybe 3, -3. I'm not going to go any further than that. Okay. Why? Because I'm feeling nice. You're welcome. Walk me through this. Megan, help me out. Okay. 2, good. All right. Uh-huh. Good. Okay. Yep. 252. Congratulations. You just found a root. X equals -1. Now, what should you check at this point? Katie. You got a root, congratulations. What should you check next? Pretend this is a test. Congratulations, you just pulled x equals -1 out. How many roots are left, first of all? 3. So what is this in real life? 2x. To the third, yeah, plus. Yep, plus. Plus. -252. What should you? For those of you listening at home, the screams and yells over yonder are a new class at Sacred Heart Academy. It's being thrown to Lions 101 in simulation of the old Coliseum. It's actually, it's an elective. You can only take it once. I'm kidding, but I always do this when I'm being recorded. I'm so dead. But anyway, what could possibly happen here? Maybe, if we're lucky. Yeah, go ahead. It might factor by grouping. As a matter of fact, it does. Go for it.
Negative x squared.
Good, negative x squared.
And x minus 7.
Oh, actually there's
Oh, negative.
2x.
2x.
And then minus 7, good. Plus, what comes out of here? What better come out of here? I'm hoping to get a 2x left over. What would have to be yanked out? 36, very good. And what are we hoping to get here?
2x minus 7.
That, by the way, is exactly what you get. Go for it.
Well, 2x minus 7.
Yeah, so 2x minus 7 in front. Okay.
Negative x squared plus 36.
Negative x squared plus 36. All right. Yeah, question.
Everything on that one is a little off screen.
Oh no! Okay, thank you. At least this thing can move a little bit more easily. Oh, so people listening at home, you might have been totally confused. This is what I just put on the board. So, wow, so the last 5 minutes would have been a complete mystery. Welcome to my life. So here we tried to pull out a root of 1, didn't work because the answer was not 0. Tried to pull out a negative 1, it did work, congratulations. And then the stuff left over, turns out it factors by grouping. Let me move this back over here, so hopefully it's not off screen again. Thank you for telling me that, by the way. I would not have known until it was too late and started getting a negative x squared plus 36. Question, does anything in there factor again? Mm-hmm.
You pull out a negative 1.
There is a GCF here of negative 1. So let's pull the negative 1 all the way out in front. The 2x minus 7 doesn't change, but what does this turn into?
X squared minus 36.
Oh, interesting. Let me see. Blaze, does anything else factor?
The x squared minus 36.
Yeah, what does that become?
X plus 6, x minus 6.
Correct. What technique was that?
Difference of 2 squares.
Difference of 2 squares, good. And this is negative 1. Now, how do you find the rest of the roots? Josh.
Just so you go to 0.
Right. Do it. So I've got 2x minus 7 equals 0, x plus 6 equals 0, x minus 6 equals 0. Go ahead and these two you can probably do in your head.
Negative 6.
Negative 6,
And 6.
6. All right. And then,
Subtract 7.
sort of, they subtracted.
Add 7.
Add 7. So 2x equals 7.
Go back up.
What do you got?
7
Good. So you've got 4 roots. X equals negative 1, x equals 6, x equals negative 6, x equals 7 over 2. And you might notice 7 over 2 is one of our options. Just so you know. Now, why did we do all that if we're going to be graphing? Oh, math people. Why torture ourselves with all of that? And why torture ourselves with doing something that's off screen? Moving back. I hope nobody gets seasick at home. There we go. Okay. So, why did we do all that? Hey.
Oh, they're all x-intercepts.
Those are x-intercepts. We should be able to graph this thing now, more or less. At least we can graph the x-intercepts. We got one at negative 6. We've got one at positive 6. We've got one at negative 1. And the other one was at 7 over 2, which is 3.5. Which is 3.5, so 7 over 2. All right, math people. What shape, here's the original polynomial in standard form. What shape is that? See who remembers the shapes of polynomial. If it were degree 2 positive, it would be a parabola going up. If it were degree 3, it would be one of those up, down, up things. You may want to, yeah.
Is it upside down?
What's a degree 4 thing gonna look like?
W.
It's a W. What if it's upside down? Yeah, it's kind of like McDonald's. McDonald's is not paying me for an advertisement, by the way. It is an upside down W. So it's sort of an M shape. That should give us some idea of what this looks like. You do not necessarily have to have all of the points. There is one more point I would like you to find. That's relatively easy to find. It's absolutely insane to graph, but it's easy to find. Bless you. Can anybody find out what it is? I give you a hint. We just got 4 x-intercepts. What other point might we be able to get relatively easily? Go. The y-intercept. How do you get the y-intercept?
0 for x.
0 for x. What would you get?
Negative 252.
Negative 252. Yeah, I know. Way down here, let's just fast forward down here. This is negative 252. There's your point. So here's what I'm going to do. It's got to be a sort of an M shape. And you notice the space between this and this is pretty close, and the space here is a little bit less. Think of the dog running, and you have like 5 minutes or 5 seconds for the dog to run and then come back. And then this is, what is it, 1, 2, 3, 4, 4.5, which is almost the same. And then you have like 2.5, which is not nearly as much time. Tell me what to do. Where should I start? Let me see. Megan, help me out. Would I start below or above? Below, because the M shape starts below. Okay. Is this a single, double, triple root, quadruple? Single. So what does it do? Goes straight through. So I'm going to plow straight through. And I'm just going to guess how high it goes. And then what has to happen? Come back down and hit what? Correct. What kind of root? Single. So it does what? Straight through. Good. Katie, take over. What happens now? Thank you. Yeah. By the way, this is probably like 250 or something. It's really, really high. And then it goes down to the y-intercept, and then what? Yeah, what kind of a root is that? Single. So what does it do? Yeah. How high does it go? Does it go as high as this one? No, it doesn't have as much room, so it only goes like halfway maybe. And that's your answer. Does that make sense? That was brutal as far as getting the x-intercepts. I'll be the first to admit that. But, do you see how we get it? Yeah, question. Yeah.
Sorry. Wouldn't it have to be a dotted line and open dots? Because there's no.
I'm an idiot. Okay, thank you. Thank you. Yeah, point. These people, I need a nap. You figure I'd have enough for a break. Y is greater than. Wow, I get so proud of this. The people at home, you probably can't do this because you can take an eraser if you're doing pencil. I'm cheating here. I'm just making this a dotted line by doing this. Does anybody see why it has to be a dotted line? Like I forgot to. Because the original problem has y is greater than. There's no equals. Let me just keep making my line dotted here. My fingers are going to be totally blue by the end of this. There you go. These should actually have been what kind of dots? Anyway. Come here, Chloe. Second. Open dots, exactly. Good. They should be open. And open. Does that make sense? I should have checked that before I went all Looney Tunes. There's one last thing we need to do. Josh. Shading. Does anybody remember the shortcut for shade? Like, what's the standard way to find out for shading? Which way do you shade? How do you find out? Plug in any point you want, as long as the point's not on the border. What point is easy? 0, 0. Let's try 0, 0. I'm going to put a little X on 0, 0. Try 0, 0 for me. So we're going to test 0, 0. Go for it. What's this going to be? 0 is greater than what? You can simplify right away. Negative 252. Is that true or is that false? It is true. 0 is bigger than 252. Think temperature. 0 degrees is warmer than 252 below, which might be absolute 0 or something. No, it's Kelvin. Never mind. 273 point something below 0 is Kelvin. Never mind. Long story. But which way do we shade? This came up true. Blaze.
Shade above.
You shade above it. Correct. The dot is above the border, so everywhere is a border, it's going to shade above it. There you go. Yeah.
Should the y-intercept also be open up?
Yes, it should. Oops. Thank you. Questions? Yeah.
Will the test you want us to include the y-intercept?
Let me see. Let's put it this way. If I do, I'll tell you.
Okay.
The only things absolutely necessary are the x-intercepts, because that'll give you some idea where the graph is. The y-intercept might help because it also tells you that it's going down at that point. Okay. Questions so far? All right, I'm going to have to erase a lot of that in order to have room for the poor souls at home who can only see the middle board. Number 2, much, much more merciful than number 1. You're welcome. Let's see what we can do. I'll start over here. Now, people watching at home, you can just rewind and then freeze frame. People here, if you're still writing down notes, I'll give you a few extra minutes. 3x squared minus 26x equals 16. And they have less than or equal to 0. I want less than or equal to y. Can somebody put this in the right order? Becca. I want y first. So how would you fix this?
Y is greater than or equal to,
Yes.
and then 3x minus 26.
26x plus 16. Good. So let's look at this form. Can anybody tell me, just out of curiosity, the standard way to find out which way to shade is to test a point. Does anybody remember the shortcut? It only works if you have a letter by itself. Yeah.
Well, if it's the letter by itself, you just look at whether it's greater than or less than.
Right. It says y is greater than. Now y is either up or down. What does y greater than suggest? What direction?
It's above.
Up. Correct. And that's exactly what happened. If you have a letter by itself, that's a fast way to shade. If y is greater than, you're going to shade up. If y is less than, you're going to shade down. Greater than or equal to, you shade up and make the borders solid, and so on. If you had x is less than, what does that mean? If x is less than, yeah,
You left.
shade to the left, right? Correct. Sorry. And then if your x is greater than, you shade where? Okay. If x is greater,
Into the right.
you shade to the right. Correct. Does it make sense? Yeah. Please.
How would you shade to the left or right?
In this one, it would be horrible to do that. Yeah. And by the way, getting it, that wouldn't be the worst thing. Trying to get x by itself on this is like, yeah, forget it. I think it's actually mathematically impossible. Or no, it's possible, but it's like insane. I've seen, you know the quadratic formula?
Yeah.
This is a quick 30-second story. There's something called a cubic formula, where you can take anything to the third power, and there's a formula you can get all 3 roots. It is crazy. I had a fellow math teacher at my first job, sat down, we had a 1-hour lunch period. We really enjoyed that. And we took the entire hour lunch period cranking through one problem in the cubic. The cubic formula is about 2.5 pages long. It's not negative b plus minus square root of b squared minus 4ac divided by 2a, which you could fit in a postage stamp if you write small. This thing was bonkers. You had to do like 5 different stages. You have to do this and then this and compress it to this and blah, blah, blah. You know how you do complete the square and you make it into a square? You have to like complete the cube and make it into a cube and then force it into a weird thing and then force it through the quadratic formula because you make it a sort of a pretend quadratic. It was bonkers. We got it. It took 55 minutes. We finally got the right answer. But that was just doing a problem. That wasn't proving it or anything like that. So it's off my bucket list. I've said I can do the cubic formula. There is a quartic formula. There is a formula where you can get all 4 roots. And it's even more insane than the cubic formula. It's like 5 pages. There is no formula above degree 4. And there's a mathematician who proved that there never will be. Anything degree 5 and above, there is no formula to solve ever. The mathematician's name was Abel, A-B-E-L. It looks like Abel, but he was amazing. Is that there was no quintic formula, etc. All right, back to normal. Can somebody tell me how to solve this thing? Wow, that was almost. I think I might even have had that. I didn't quite thwack myself in between the eyes like last time, but go.
You do magic pair.
You can do magic pair. Hopefully it works. Go for it.
48x squared.
Okay. And then looking for a pair that adds up to negative 26. Is there one?
Yeah, negative 24x
Uh-huh.
minus 2x.
Times negative 2x. Very good. That's the magic pair. What do you do with it?
You plug it in.
Right. Plug it into the middle. So you've got 3. What am I doing? 3x squared plus negative 24x plus negative 2x plus 16. Take over, Josh. Factor by group here.
So you take out 3x,
Uh-huh. And what's left?
x plus, that's negative 6,
Negative
negative 8.
8. There you go. Plus what?
You take out
Negative 2. Good. And then what?
x minus 8.
Yeah, x minus 8 is fine. Is this going to work? Good. Blaze, take over.
Shake up the
Okay. I'll even write it as x minus 8 for old time's sake. And then what's the other one?
3x plus 2.
Yeah, 3x plus negative 2, 3x minus 2. How do you solve that thing? Katie, take over. Go for it. What's this one going to give you? X equals 8. Anybody know this one in their head? It's a two-step problem. Anybody know it? Yeah.
2/3?
X equals positive 2/3. Add 2 to both sides and then divide by 3. So we've got root, and that's it. Now we're supposed to graph it. Tell me how. Mikla, where do I go? Yeah, so I've got 2/3. I'm going to totally wimp out and just declare this as 2/3. And then there's one at 8. Is this a parabola that's going up or down? How do you know? Yeah. Right. It's a positive quadratic. So it's positive parabola. It's going uphill. Where's the, oh, you could probably find one more point for me. One step is where?
16.
As it's 16. Which kind of makes sense. So it's going to go down, hit somewhere, and go up. Do you have to find the vertex for this particular problem? No. And thank God there's an equal sign, because I just mindlessly drew that thing again. So, less than or equal to means that the border, is it solid or dotted? Josh? Don't even be nice. So, this thing, solid, correct. So the thing is solid. You don't need the vertex, because all I need is a basic sketch. But there's one thing missing. Becca, what do you think? What's missing out of this graph? We're almost done. There's one thing, what?
The shading.
Shading. Where would you shade? And there's a quick way to do it.
You plug in 0.
You could definitely plug in 0, 0 and see what it is. You've got a letter by itself. There's a shortcut. If it's a letter by itself, just look at the sign and follow it. What do you think of, what direction do you think of when it's y is greater than? Now y is one of two directions, up or down. What is y is greater than?
I don't know.
Well, up is what kind of numbers?
Positive.
Positive. Are they bigger or smaller than the negatives?
Bigger.
They're bigger. The higher up you go, the bigger you are. So if y is greater than, you're going up. And that's exactly what we do. We shade above the border. So it kind of looks like we shaded inside. We're really shading above it. Questions? Does that make sense? Yeah, this is a workout. I'll admit that. Let me give you a couple of, any questions on that before we go on? Number 3, oh my word, 15 minutes. I can do this. All right, any questions on this? Let's take a look at number 3. I want to step you through and I want to give you a technique. It's a technique you already know. So let's just start this. I've got 2x squared, and I apologize, they wrote it, wow. Tell you what, you know number 4? Did anybody start number 4? I'm sorry. Scratch it off. Just put a bullet in it. It's intense. So this one is, I'll explain why in a minute. 2x squared minus 4x minus 96. Over 2x squared plus 11x plus 21. I think that's right. Yeah. And they have greater than 0. What I'd like to do is greater than y. You might piece together why I scratched off number 4. There's no easy way to put a y in there, because you have to replace 0 with y, and they don't have a 0 yet. What you would have had to do is get both of those fractions onto one side, get a common denominator, and squish them all into 1, and then put the y in, and then you'd start the problem. That's, no. If this blah blah blah, Blaze, help me out. If this blah 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 is greater than y, then what must be true?
Y is also.
Then y is less than. I'm just going to cheat and do this. Can somebody tell me how to graph this beast? Now, you might have some roots. Where do you look for them? Sorry, at the top. The roots are on top. What do you find in the bottom, Joey? Asymptotes. Vertical asymptotes. What if you happen to have something that's identical on top and bottom? Nick? They cancel and make a what? A hole, correct. There would be a hole. We don't know if there's one in there or not. The top are going to be roots, the bottom are going to be vertical asymptotes. And if you get lucky or unlucky enough for something to be identical on top and bottom, that'll cancel and make a hole. Can somebody tell me how to tear apart the top? Katie, start me off. How do you find the x-intercepts? Yeah, it's factor this thing. Does it factor? Yeah, there's a GCF of 2. What's left behind?
X squared minus 2x
Uh-huh.
minus 48.
Yes. So this is, let me just show the world where this is coming from. Does this thing factor? Megan, take over. If it does factor, what method might work? Just ignore the 2.
Just unfoil.
Unfoil. Can you think of 2 numbers that add up to -2 and multiply to be -48? Nice. X minus 8, x plus 6, and there's still a 2 in front. How do you find the x-intercepts? Set it equal to 0. Go for it.
X equals 8.
Good.
X equals -6.
Good. So we've got 2 roots at x equals 8 and x equals -6. So roots. X equals 8, x equals -6. The 2 does not give us any roots. It's just high multiply. Can somebody tear apart the bottom for me? Becca, take this one. What method would work on this thing? If it does at all.
Did you do magic there?
You could do magic pair. By the way, God forbid if magic pair doesn't work, if it's prime, that doesn't mean the solutions aren't there. Does everyone remember the one last resort thing that can tear apart something of degree 2? I had you memorize that. Go. The quadratic formula. You could do the quadratic formula on the bottom. And you could do it right away, by the way, if you love the quadratic formula. it'll do that for you in one step, one big, huge, painful step, but it'll do it. Let's try magic pair though. So Becca, take over. What do you got?
42x squared.
Almost.
Oh, negative 42.
Yeah, negative 42x squared. And I want a pair. Is there a pair in there that adds up to a positive 11x? Let's go through it. Oh, did you find them?
No.
Okay.
I don't know.
So it's 1x times negative 42x. Keep going. Does 2 work?
Yeah, 2x and
Negative something. Negative 21x. 3? 3x times 3 is under 40.
14.
Yeah, 14. Negative 14. Let's stop for a second. What are we looking for? They add up to what?
11x.
11. What does this add up to?
Negative 41.
Negative 41. How about this?
Negative 19.
Negative 19. How about this?
Negative 11.
Negative 11. How interesting. Is that what we want?
No, that's close.
It's close. Hyper warp down to the real one. What is it?
Negative 3x
Uh-huh.
and 14x.
Got it. There's your magic pair. So take over, Blaze. What do you do with this? That's a magic pair.
Oh, you replace it with, or you replace the 11x with it.
Right, so plug in for the 11x. So we've got 2x squared plus negative 3x plus 14x plus negative 21. Keep going. What would you do now? Back to by grouping. This is what comes out of the first pair.
X,
X, and then what's left behind?
2x plus negative 3.
Yes. Keep going.
7.
7, good. And then 2x
2x plus negative 3.
plus negative 3. Is this gonna work?
Yeah.
Go for it.
2x plus 3.
Okay, that pulls out in front. So 2x minus 3. And then what's left behind? Sorry.
X plus 7.
X plus 7. How do you solve that?
So equals 0.
Right, set it equal to 0. What do you get? This one, what do you get?
X equals negative 7.
Good. And this is?
X equals 3 over 2.
Good, x equals 3 over 2. What are those objects?
Asymptotes.
Yeah, vertical, horizontal.
Vertical.
They're vertical asymptotes. They're at x equals negative 7 and x equals 3 over 2. Question, did we have a duplicate on top or bottom? No, so nothing cancels. So if you break this thing apart, it looks like this. Y is less than, parentheses, the top is 2x minus, oh wait, no. This was, oh, it's 2 parentheses, x minus 8, parentheses, x plus 6. And the bottom is parentheses 2x minus 3 and x plus 7. So nothing cancels, so there are no holes, so you don't have to worry about those. How do you graph this monster in the 7 minutes we have left? Yeah, go.
Do you do like the positive negative thing first?
Ah, interesting idea. I heartily approve, by the way. Plus minus notation. What does plus minus notation tell us? Like it's, yeah,
Like what side of the X?
yeah. What side the x-axis is on?
Yeah.
In other words, whether it's above or below. List the breakpoints for me, America. Okay, 8, which is, is that the biggest one? Yeah, so it's probably, okay. Is that a root or a vertical asymptote? Root, it's a solid dot, okay. What's the smallest one? Negative 7. What's there? Vertical asymptote, okay. Negative 6 is a root, okay. And 3 over 2 is a vertical asymptote. Okay, break these into regions. All right, plus minus notation experts. Oh, math people. Oh, Katie. Go for it. How do you do plus minus notation?
So
Let's call this region A.
you would just pick a number and
any number you think is convenient. 0 sounds good. That's region what? Region C. X equals 0. So y equals, here's the compressed version. So it's 2, which is automatically positive. And then and then the bottom is paren. Pretend x is 0. Positive or negative? Negative. Keep going. Positive, good. This one? Negative, good. Positive. How many negatives total? 2. What does that make it? This region is positive. Now, Megan, help me out. This is a single vertical asymptote. Will that switch the sign?
Yes.
Don't read my thoughts. What? If it's a single vertical asymptote, would it switch the sign jumping over it? Yes, it would. Correct. And do one more. Jump over a single root. Does that switch?
Yes.
Maybe? Don't read my face. Tell me why. It goes through. It goes from top to bottom or bottom to top. The two things that guarantee a sign switch are single roots, single vertical asymptotes. Also triple roots, triple vertical asymptotes. Quintuple roots, quintuple vertical asymptotes. Anything with odd powers is going to flip the sign for roots and vertical asymptotes. Wholes usually don't, unless they're the result of a war, which we'll talk about more tomorrow. Take over, Jayla. Start at region C, jump over -6. Is that going to flip the sign? Yes. Yes. How about jumping over -7?
Yes.
Yes. So that should tell us, normally we just say, where is the region less than 0 or something like that. I want to actually use this to help sketch the graph. So I'm going to mark -7. I had to do these dashes, didn't I? All right. Here's -7. Here's -6. Here's 3 halves. And here's 2, 3, 4, 5, 6, 7, 8. Here's 8. So 8 is a root. -6 is a root. -7 is a vertical asymptote. And 3 halves is a vertical asymptote. Okay. Help me out. Anything at your disposal to help graph this thing? Can somebody give me anything whatsoever about this problem? Like where to start, or what region goes where, or what? I will say this, all the roots are single roots, all the vertical asymptotes are single asymptotes. Go.
Could you start from?
Well, I'll give you a hint. Start at region A. What does that include? All the x's that are what? Yeah, well, it's above. So region A is everything left of -7. So where should I draw it? Should I draw something above or below? Above. Does it ever cross below as it goes to the left? No, it would show up. You'd have a root and you'd have another negative. So it has to stick in here. I don't know quite what it's doing. It might go wibble, wibble, wobble, wobble. I don't care. As long as it stays above 0, I don't care. So it's going to, question mark. What's it going to do as you get closer and closer to -7? Keep going up. Could it go down and follow the asymptote here?
No.
Why not?
Because it crosses it.
It would cross and make a root. Correct. So this has to go straight up. That part's done. Can somebody tell me where it reappears? No.
On the bottom, under -6.
Yeah, between -7 and -6, it comes from below. What makes you say that?
That's because in
2 reasons.
notation it's negative.
Yeah, that's the easiest one. It's negative in between -7 and -6. Also, a single vertical asymptote, do they swerve the same way or opposite ways?
Opposite.
Opposite. So that covers that. What happens when you get to -6?
It goes through it.
Goes through, correct? And then what?
Leans towards the other vertical asymptote.
Yes. Does it ever come back down?
No.
Why not?
Because then there'd be another x-intercept.
It would make another x-intercept, which we do not have and don't want. So the only thing we can do is this. Does that make sense? It has to go up, and it has to avoid the asymptote. And you could probably find the y-intercept. I don't know where it is, but who cares? What happens on the other side of 3 halves? Very quick. Does it appear from above or from below? Below, correct. What does it do now? H, and what does it do there? Goes through, and then what? Does it come back down ever? No. I'm not 100% sure what it does, if it flattens out or just torpedoes up. We don't care, as long as it stays above. That's your graph. Now there's one catch. I did it again. It's supposed to be a dotted. People watching at home, you've gotten my, like more doses of my stupidity than most places combined. You're welcome. Normally people have to pay good money to see that. So, okay, this dotted, this is supposed to be an open dot. This is supposed to be an open dot. One last thing. Wait, I know we're done. We're almost done. One last thing missing. Shading. Which way do you shade? Down. Y is less than. So you shade below here, in this region, below here, in this region, below here, and below here. Done. Okay? Congratulations, you have no homework for tomorrow. I figure it's only fair because I tortured you with problems 1 and 2 at a time. Please stand. And people watching at home, in case you didn't catch that, there's no homework for tomorrow, for Wednesday. Merry Christmas early. Happy Hanukkah. Please stand. We're going to do the prayer one more time. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Hail, and blessed be the hour and moment in which the Son of God was born of the most pure Virgin Mary, at midnight in Bethlehem, in piercing cold. In that hour, vouchsafe, O my God, to hear my prayer and grant my desires, through the merits of our Savior, Jesus Christ, and of his blessed Mother. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. All right, see y'all later. People watching at home, take care. See you soon, God willing. Bye-bye.